called image classification using CNN, that is convolutional neural networks algorithms. So now coming to the introduction part, image classification using convolutional neural network algorithm is a powerful algorithm that has revolutionized computer vision applications. By mimicking the human visual system and utilizing a hierarchical approach, CNNs can efficiently learn to identify and classify complex patterns in images, providing us with unprecedented accuracy and insight. With ongoing advancements in deep learning and hardware technology, CNNs continue to shape the future of image analysis and understanding. Next, pooling layers are employed to reduce the dimensionality of the feature maps while retaining important information. Pooling involves taking the maximum or average value from a specific region of the feature map, thus reducing the computational complexity and making the network more efficient. So now coming to the objective part for this project, the image classification using convolutional neural network algorithm is to create a highly accurate and efficient algorithm for automatically categorizing images into predefined classes or labels. CNNs have emerged as the state-of-the-art method for image classification tasks due to their ability to extract and learn meaningful features directly from the raw pixel data of images. Traditional image classification algorithms heavily relied on handcrafted features, which were often time-consuming and limited in their ability to capture complex patterns. CNNs, on the other hand, automatically learn hierarchical representations from the data, allowing them to identify and understand intricate details and variations in images. By leveraging the power of deep learning and the convolutional neural networks, layers, local connectivity, and weight sharing, CNNs excel in recognizing patterns irrespective of their position in the image. This feature makes CNNs robust to image translations and help them achieve high levels of accuracy even with limited training data. The ultimate goal of image classification using CNN is to build models that can generalize well on unseen data, enabling real-world applications such as self-driving cars, medical diagnosis, security surveillance, and much more. So now coming to the requirements part, we have two types of requirements, that are hardware requirement and software requirement. In hardware requirement, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDE, that is 3.7 version is required. Now coming to the methodology part, first generate CNN train and test model. In this step, you train the CNN model using a labeled dataset of images. The dataset consists of images along with a corresponding class label. The training process involves feeding the images into the CNN, updating the network weight using backpropagation optimization algorithms, example gradient descent, and it's iteratively fine-tuning the model to minimize the classification error. After training the CNN, you need to evaluate its performance on a separate data that the model has never seen before. This dataset is called the test set. The purpose of the test set is to assess how well the trained model generalizes to new unseen data. The test set evaluation provides valuable insights into the model's ability to classify images accurately and helps determine whether the model suffers from overfitting, that is, performing well on the training data but poorly on new data, or underfitting, failing to capture the underlying patterns in the data. Second, upload test image. In this set, you can interactively provide a test image to the trained CNN model. This allows you to observe the model's classification performance on a specific image of your choice. You can upload an image from your local computer or any other accessible source. Third, classify picture in image. After uploading the test image, the CNN model processes the image through its layer, extracting relevant features and ultimately classifying it into one of the predefined categories or labels. The classification output reveals the predicted class of the image based on the learned patterns from the training process. Fourth, exit. Once you have tested the model on the desired image or completed the classification task, you can choose to exit the program or return to previous steps for further evaluations or testing on different images. So now coming to the execution part, to execute the project, first we need to open the code folder. So here we have a folder named as data. In this we are containing two folders, that is train and validation. And in all these we are also containing some of the folders. And in all these folders we are containing some images over here. And another folder named as test images. In this we are containing some images for testing it. So here we have another data set which is containing named as model, which is containing some data set over here. And here this is the .h5 files which contain the deep learning algorithms information. These .h5 files can be loaded into the project code during runtime to utilize the trained model for various tasks, such as making predictions on new data and performing specific operations. And here this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. So now here this is the graphical user interface. With this we are interacting with the program. So now click on generate CNN train and test model button to generate CNN model with all images given inside the data folder. In this application I am building CNN model with car, cat, dog, plane and person images. This application can identify and predict images up to 90%, and this CNN can work up to 100% also, but we need to train it with all possible images and high processing CPU. So in this normal CPU, my generated model can identify the images with 90% accuracy. Now here, click on this and you can see that CNN model generated on train and test data. So here for you can see the black console for details. So now click OK over here, and so here you can see the black console over here. So now click on upload test image dataset button to upload the image. So here I am selecting this image. And now click on open button to upload the image. So here it is showing that image file loaded. Now click on OK button. So now click on classify picture in image. Here you can see that the image contains dog over here. So now closing this image, click on exit button to exit with this application. So you have ended with the application over here. So now coming back to the conclusion part. As hardware technology continues to advance, enabling more extensive and faster computations, CNS deployment in real-world scenarios will become even more feasible. With ongoing research and innovation, CNNs are poised to unlock new possibilities in image analysis and continue to drive progress in the broader field of artificial intelligence. Overall, image classification using CNNs have paved the way for a new era of automated and intelligent image understanding with far-reaching implications for society and industry alike. With the advancements in deep learning techniques and the availability of large-scale labeled datasets, CNNs have achieved remarkable accuracy and surpassed traditional methods. Their versatility and adaptability have made them a fundamental tool for various applications, from object recognition to medical image analysis.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.